Hi and welcome to another class of the Making Music with Arduino. In the last class, we learned about how to use the MIDI library, and we used our circuit with a button to send one MIDI note to Ableton Live. So for this, we also used the headless MIDI, which is a serial to MIDI converter, because MIDI and serial are different protocols. And because Arduino works with serial protocol, we need this software to convert the serial protocol to MIDI protocol. So the flow is the button that goes to the Arduino. Arduino sends serial through the USB. The headless MIDI converts to MIDI, and then we use the YAC driver as a virtual MIDI port, and this MIDI port communicates with Ableton Live. So there's a way that you need to go through, but we do this in the first time. We make all the configuration, but then after you get used to, it's really easy. So in the class today, we're gonna use 3 buttons. And in the end of the class here, we will understand some things, and I wanted to use this example, what we would need to do in order to use 3 buttons, and in the circuit too. In the circuit, the circuit is the same for every button. We have 3 10K resistors, and in the code is it's the following thing. Here I declared my variables: button 1, pin 2, button 2, pin 3, button 3, pin 4. The first 2 pins, digital pins in the Arduino, we use for communication, so we are not going to use them here. We will use from the pin 2, okay? I will continue using my LED, my embedded LED in the pin 13. And remember that for you to compare the previous state with the actual state, for you to not send all the time that the button is pressed, we store the state of the previous state in one variable and the actual state in another variable. And if they are different, we send a note on or a note off. So here I had to create more variables for button 1, the actual state, and the previous state. And I had to do this for each button. Button 1, 2, and 3. Here in the void setup, the beginning of our code, I have my MIDI begin. I have my serial begin in our baud rate for headless MIDI. My LED, and here I put as an input my 3 buttons that I declared before. So here in our loop, first we need to store the information of each pin or each button. So you need to think that the code is always read in a linear sense, so it's like line by line. So something that you need to understand, that it doesn't do several things at the same time. It does one thing at a time, but really fast. So it seems that it's all at the same time. So we will read the state of one button with digital read button 1 and store. Then read second button and store. Read third button and store. So here you see that the code is a little bit bigger. So here I have a series of if statements that actually is the same thing for each button. So if the previous state is different from the actual state, if it was pressed and now it's not, do this. If it's pressed, digital write LED, it will turn the LED on and will send the note 36. If it's not, we'll send 36 but velocity is 0 and we'll turn the LED off. Same thing for button 2, but with note 38, and for button 3, the note 42. So I went there in my table and I saw the kick on 36, snare 38, and hi-hat 42. And here in the end, I store the last state of the button. So I will store the last state in the button p state variable. So let's upload this code. And let's see, it's uploading. Okay. Let's open the hairless MIDI. And here you can see in the preferences that here you have more baud rates actually that you can use. So that's why we put 115200 because it's the fastest, and the fastest the better. Let's initialize here. So note 36, note 38, note 42. Let's open Ableton Live. Now we can open a drum rack. So let's come back to the code. So for example, we used 3 buttons. So for each button, I used these if statements and I copied the 3. So imagine if we are using 100 buttons. We will need to make 100 copies of if statements, or 1000. Imagine how confusing it would be with 1000 copies. So this module was for you to get used to do a prototype in the protoboard and how are the connections and the theory and the basics of the code of how to send a MIDI note. But for you to make a more professional MIDI controller that won't have those problems, you need to take a step further. You need to learn how to use other components, leave the protoboard, and do some techniques that I use in my controllers that you don't copy lots of if statements. So there's a method that you can actually use for several different MIDI controllers that you can just change a couple things in the beginning of the code that will adapt to any amount of buttons or potentiometers in a really small code. And that's what we're gonna see in our next modules, besides the other things like building in a case and using other kinds of components that will be really useful for our controllers. So that's it for now, and see you next class.